In this video, I'm going to talk about limits of a function. In our case, the function is f of x is equal to 0 if x is less than 0, and f of x is equal to cosine of x if x is greater than or equal to 0. So let's kind of sketch it and see what we get. This is how the function looks like. This is your x and this is your y. So it's going to be 0 to the left, okay? So it's going to, let's put a circle here. 0 if x is less than 0. On the other hand, if x is greater than or equal to 0, is going to be just cosine of x, whatever it comes out to be. We know that cosine of 0 is 1, so I'm just going to put it at 1 here. Then it just behaves like a regular cosine function, okay? So it's going to go down and create the wave and whatnot. So I don't care about the rest of the functions. Now, our objective here is to find the limit of this given function as x approaches 0. So in essence, we are going to find limit x approaches 0, f of x. We want to find that. So to find this, we are going to kind of take a slightly different approach here. What we are going to do, we are going to approach the point 0. So x is equal to 0 is right here, right? We are going to approach the point from the left. That is to say that I'm going to go from left to the right towards 0 and try to find out what the value of the function is. Now, as we know that the value of the function is 0 if x is less than 0. So let's create a sequence. Let's say my sequence is -1, -1/2, -1/3, -1/4, and it keeps going. The numbers are increasing going towards 0. Now f of -1 is 0, f of -1/2 is 0, f of -1/3 is 0, and as you can see, all of them are 0. So the limit for this function, if we approach the point 0, or if x approaches 0 from the left-hand side, from this side, is nothing but 0. So the limit, so let me write it out, limit x approaches 0 from the left side, f of x is equal to 0. Now let me introduce here a bit of notation. If you are approaching a point from the left-hand side, it's conventional to use a negative sign on top of the point that you are approaching. So we are approaching 0 from the negative side. All right? So that's what I get. Now what I'm going to do, I'm going to approach 0 from the positive side. So let's create another sequence. Again, it's going to be 1, 1/2, 1/3, 1/4, keeps going. And you can see it's going to be cosine of 1. I really don't care too much about what happens to this value. What is the exact value is, you can find it out. Then cosine of 1/2, then cosine of 1/3, right? Cosine of 1/4. If you find these values, you will see all these values are going lower and lower and lower and approaching a value. And that value is, by the way, 1. We know that cosine of 0 is 1. So all these values are going to approach 1 sequentially, gradually approaching the point 1. So the limit x approaches 0 from the right-hand side. Again, a bit of convention. If you are approaching from the right-hand side, you put as a superscript positive sign. Okay, so it's going to be limit x approaches 0 from the positive side, f of x is equal to 1. We have approached the same point. Once from the right and once from the left. However, we got two different values. If we are approaching the point from the left, we get a 0. If we are approaching the point from the right, we get a 1. They are not equal. Therefore, the limit for this function as defined at 0 does not exist. Does not exist. Here I want to emphasize the fact that if the limit at a point for a function does exist, in that case both left limit and the right limit must be the same. Once again, if limit for a function at a particular point exists, then the left limit, that means if you approach the point from the left versus if you approach the point from the right, which is the right limit, both of these limits must be equal. So let me go ahead and define this thing here. If limit exists, if limit exists for a function f of x at x is equal to some value a, then it must be the case limit x approaches a from the negative side, f of x is equal to limit x approaches a from the positive side, f of x is going to be exactly equal to the limit x approaches a, f of x. So it doesn't matter which side you are approaching from, the values should converge to the exact same values. And I'm going to kind of extend on this idea a little bit, by the way. In the case of number line, there are two directions, right? So if this is the point A, you can either come from the right or come from the left. But I'm going to granularize it or make it even finer, more finer by doing the following. Let's say you come from the right. You don't have to compare the right and the left necessarily. You can compare the right side only by taking two different paths. So you can approach this point A, right, by taking one sequence. Let's call it sequence 1. And you can approach the same point A from the right hand side again, approaching or taking a different sequence. Let's call it S2. I call them by taking two different paths, okay? You are approaching the same point. You must always get the same result regardless of the path that you take, meaning that whether you take sequence 1 to get to the ultimate destination of A or you take sequence 2 to get to the ultimate destination of point A, it shouldn't make a difference. It should always give you the same result, same limiting value. I hope that this discussion was helpful. Thank you very much.